Okay, so let's talk a little bit about the core ideas of FOLT. Hmm. So, why do we care about language at all? So, there are several points that we can make in this context. First of all, this complex form of language that we are using is entirely unique to humans among all the species of the world. So, there are several species that have some primitive forms of communication, but humans uniquely have a very complex form of communication, and we use this form of communication every day. We use it to communicate our sorrows. We use it to communicate what we want to buy. We use it to communicate all kinds of things, right? So language is really central to human existence. So that's why we should naturally care about language. Secondly, all of the world's knowledge, or like most of the world's knowledge, is actually encoded in text, and this does not only relate to like knowledge about the past, such as in the books or in books that relate to ancient cultures, such as the ancient Romans or the ancient Greeks, but also we can just look at the World Wide Web, which contains massive amount of information, and most of that is really in textual form, right? It's like people writing in Wikipedia, people exchanging ideas on different communication platforms. So this is a huge source of knowledge, and to query this source of knowledge, we really need automatic tools that allow us to process the knowledge in adequate amount of times. Thirdly, if language were a simple task, then probably we would not need courses about it. But on the very contrast, language is a very challenging task and requires competences from multiple disciplines such as psychology, physics, sociology, mathematics, etc., etc. And that language is challenging. You can already confirm yourself by your own experience. For example, when you learn a new language, right? You need to learn all those grammatical properties, and that is for some people very painful. And some people do not even manage to learn a single foreign language, right? So there you can even see how difficult language learning is for humans. And even like native speakers, human babies, they take several years to be able to master language on an adequate level. And nowadays, when we talk about language processing, there are the big players such as Google, Amazon, Facebook, and they do a lot with language uh, because they basically are interested in their social media and their search engines, and their everything is related to language. And therefore, nowadays we have very many interesting applications and very many interesting jobs out there, right? And the applications that we have, they really range from they really go to high level tasks nowadays, like understanding argumentation, doing machine translation, doing summarization. So these are really cool NLP tasks. Why do we use Python? Because it's a simple programming language where you can gradually learn. So there's no steep learning where like you don't understand it for weeks and weeks, and all of a sudden it dawns upon you how to use the language. But instead, you really you can learn every day a little bit because of it being interpreted, and you can try it out right away. It has good string handling, which is important because in natural language processing, we really work a lot with strings, obviously. And the interpretedness, I've already talked about. This is what facilitates interactive exploration. So you can really type something in, you see the result. If it doesn't work, you get direct feedback. So you get direct, steady feedback by using the interpreter. It also combines several programming paradigms, including object oriented, aspect oriented, and functional programming paradigms. And it has become so popular in various scientific communities and also non-scientific communities, that there's really a huge foundation of standard libraries for multiple problems available, which you can just use, and then you stand directly on the shoulder of giants and can achieve things much quicker than if you would have to invent the wheel all by yourself. Why are we going to use NLTK? NLTK is a toolbox on top of like Python. It's there to process and analyze natural language text very quickly. So you have an additional high-level toolbox on top, which allows you to do things with natural language very quickly. It has basic types and classes for representing and processing language data. It has standard interfaces for tokenization, stemming, part of speech tagging, syntactic parsing, classification. So if you want to do all those standard NLP tasks, where, for example, tokenization is the problem of how do we split up the text in tokens, right? So in usable, like we could say in words, how do we delineate individual words? But words is actually a fuzzy and undefined linguistic concept. So in natural language processing, we usually talk about tokens, which is the individual units, and you'd have to define them. Do you want to add commas to your to a token, or do you want to separate commas and punctuation from the rest of the tokens? A part of speech tagging is assigning word classes such as verb, adjective, and noun to words in a sentence, and the other task we're going to learn during the course. But as I said, the important thing is that NLTK provides standard interfaces where you can do this very easily and very readily. It also has corpora with real world data, not only like like polished corpora, but really real world data. It also has lexical resources such as WordNet, where the semantic relationships between words are stored. So this is a lexical resource designed by humans, where you have words in a network, and there's relationship between the words. So one word could be a hypernym or hyponym of another word, which means it's arranged on a higher hierarchy, such as is a hierarchy. For example, a dog is a animal. So dog and animal are related, and they are related by this is a hierarchy, such that every dog is also an animal, and these relationships are stored in WordNet. And NLTK provides these lexical resources, so it provides a lot of knowledge that you would all actually want to use when you do natural language processing. And also you can easily visualize the results. There's the NLTK book, written by Stephen Bird, Evan Klein, and Edward Loper. It is available in the library. It's what we base our lecture upon. There's a free online edition that you want to and should consult. And and importantly, we use the online version as it makes use of the latest Python version, namely Python 3. So we're going to be using that. You're happy, and we encourage you to consult the book. However, like many things that we cover in the lecture are actually so they are actually sufficient. Like if you just wanna do the minimal effort, you just go with the lecture. But we really encourage you to go beyond and look in the book itself. Now, if this were a real life class, you could rate your programming experience. And so the class is not live, so you are happy to give such feedback during the practice class, which will be on Monday. As for the course overview for Python and NLP, we build up upon a linguistic hierarchy. So this hierarchy is, today this is not part of linguistic hierarchy, but today we give an overview of the lecture. Then in classes 2 and 3, we're going to cover Python and the basics of NLTK. So you learn a lot more about how to program, how to do the computer part of the course. Then in lectures 4 to 6, we're going to the NLP part again, where we cover data, different data sources, different how to process data, what is interesting to analyze when we deal with natural language data, which lexical resources do we have, etc., etc. Then in lecture 7 and 8, we again do a little bit NLP, plus also programming, where we cover tasks, different tasks on the token level, such as tagging, right? So what is tagging? One popular use case of tagging is part of speech tagging. So this is the task of assigning each word in a text or each token in a text a label, and this label is its word class. So this could be adjective, noun, adverb, uh, verb, etc., etc. So this is part of speech tagging. This will be covered in the 7th to 8th lecture. Then 9 to 10, we do classification, which is again a little bit more on the programming and implementation side. So what are typical use cases of classification in natural language processing? So we might want to classify whether a review, let's say an Amazon product review, is positive or negative. Such information can be very useful for enterprises, for industry, right? Because they wanna aggregate whether like a product is being popular or not. The same could be done for movie reviews, where people write reviews about movies, etc., etc. So there are many classification tasks in natural language processing, which for which you may learn the foundations in the lectures 9 to 10. And then we go further up the ladder in the processing of natural language. In lecture 11, we're going to do information extraction. So there's information stored in text, such as information about entities and their relationships. What's an entity? An entity could, for example, be a person, like Joe Biden or Donald Trump. These are entities. And then you also want to infer the relationship between the entities. So, for example, that they both want to become president. So they are related by their goal to become president. Or like Trump is married to Donald Trump is married to Ivana Trump. So that's also a relationship between those two entities. And such relationships are given in are present in texts, and here our question is how can we extract such information? Then in lecture 12 we do a syntactic analysis, so we parse sentences to find out the grammatical relationship between individual words in a sentence. So you could want to find out that that like a verb and a and a subject are related in a sentence, right? Because like Bill is drinking, so Bill and drink are related by drink being the property that Bill is conducting. So this is like a syntactical analysis of a sentence, and this already infers something about the meaning of the sentence, right? So different sentences can have different syntactic analyses, and depending on which syntactic analysis they have, they may have a different semantic interpretation. And then finally, in lecture 13, we go on the top of what NLP is all about. Namely, it's all about understanding, right? We really want to understand text in order to draw inferences, in order to translate it, and in order to do different interesting properties. So whenever you communicate, the most important aspect is you want to understand the other person. That's on the top of the pyramid of NLP, and that's what we're going to do in the final lecture. So, and then there's a general note. What I want to tell you, namely, this general note is much of what we do in this course is very elementary, right? So we're gonna see classifiers for classification, for tagging, for information extraction, etc. And those are like interesting and cool classifiers, but they are not the state of the art in natural language processing. It's also because our book is from 2009 and the current state of the art really began in 2013, right? So instead, the current state of the art is based on what is called deep learning, or also called artificial neural network learning. Illustrated here on the right, both on the top and the bottom. On the bottom, we see like a graphical mathematical formulation of what a of what an artificial neural network could be. What you see is here is different nodes. These nodes are inspired by the human brain, where also the human brain has different neurons, right? So this is like a biological, psychological terminology. We have neurons; those are elementary units in your brain that can have activation, so they can activate or not be activated. And um, we have the same in this artificial neural networks, right? And the property is that the neurons are connected with each other. And when they are connected, they may influence each other. And the activation of one neuron may influence the activation of another neuron. And then we can use this finally to learn a representation of something. So in the output could be some representation. We learn the meaning of the input, so to speak, or we learn to classify something, right? So this artificial neural networks. They are inspired by the human brain, and like these were models developed in the 50s of the last century to mimic the human brain. And they took a long while until like the 2010s. Finally, people found out how to properly use them. And they led to this big revolution that we're seeing at the moment, which has like which has pushed the performances across all levels of natural language processing. And like also in industry, we have seen those big boosts in performances and what artificial intelligence and machine learning can do nowadays. So this is the state of the art. And if you want to check this, go to our course, Deep Learning for Natural Language Processing, which I've been holding in the past several years, but this year will be held by someone else. But still, in any case, you should definitely, if you're interested in going along the natural language processing path, which I would really recommend to you because that's really a very hyped field of research with very good salaries that you can earn and good research possibilities. Also, then go to our course, Deep Learning for Natural Language Processing, in the next summer semester and deepen your knowledge. And also, when you do the share task and the project where you compete with others, keep this in mind that what we're doing here in the course is elementary. And if you really want to impress us and if you want to win the share task, then you better resort to some techniques from deep learning because they are much more powerful and they'll most likely get you a much better performance. However, even though in this lecture we mostly do not do much about deep learning, there will be one lecture or like half a lecture where I'll cover a bit of a high level outline of deep learning and I'll cover some of the basics. So, yeah, so that's it for this part.